To solve a polynomial inequality like this, we want to get a 0 on one side of our inequality symbol, so we're going to go ahead and subtract 20 from both sides. That's going to give us x squared minus x minus 20 is greater than 0. And now we're going to kind of go ahead and get away from that inequality for a second, but we'll certainly come back to having that inequality symbol in there. But we want to find our boundary points, of our points that separate solution regions from non-solution regions. And so our boundary points are found by solving the equation x squared minus x minus 20 equals 0. So we're essentially just replacing the inequality symbol with an equal sign. Now to solve this, we can try factoring, or we can always use the quadratic formula. This can be factored. It's x minus 5 times x plus 4. And so our two solutions, our two boundary points, are going to come from setting each of those factors equal to 0 separately. And so we get x equals 5 and x equals negative 4. So now I want to take those two numbers and set them up on a number line. And my number line doesn't need to be incredibly accurate. I just need to make sure I put these two numbers on there in the correct relation to each other. Negative 4 is less than 5, so it should be to the left of 5. So these are the only two places where x squared minus x minus 20 equals 0. And so to the left of negative 4, that expression x squared minus x minus 20 is either all positive or all negative for every number to the left of negative 4. Same thing for all the numbers between negative 4 and 5, and same thing for all the numbers greater than 5. Because these are the only two numbers where that expression is equal to 0. These are the only places where it might change from being positive to negative or negative to positive. So in each of those three intervals that are made, we just go ahead and pick a test point that we're going to plug into our x squared minus x minus 20 expression. So here I'm going to go ahead and pick a negative 5, and here I'll pick a 0, and here I'll pick a 6. And so we're just going to plug each of these test points into that expression. Now it's actually easier for me to plug it into the factored form of that expression. And all I'm concerned with here is determining whether I get a positive answer or a negative answer. And so if I just consider the signs, that makes things a little bit easier. And so I'm just going to organize my information in a table here where I've listed out my test values that I chose, and then what signs they give us in each of those factors, and so then what the sign of their product is. So negative 5 minus 5, that would be negative. Negative 5 plus 4 would be negative. Negative times negative is positive. So that's going to give me a positive value up there in that interval. And 0 minus 5 is negative. 0 plus 4 is positive. Negative times positive is negative. So I get a negative value there in that middle interval. 6 minus 5 is positive. 6 plus 4 is positive. Positive times positive is positive. So now I have this number chart here, or this sign chart, that tells me the sign of this expression in each of these three intervals. So this is where I go back to looking at my inequality. My inequality said to find where x squared minus x minus 20 is greater than 0. That basically means positive. So we're looking for places where we have those positive signs, which would be here in this left interval and in the right interval. And so to give this solution as an interval, we'd go ahead and write that out from negative infinity to negative 4. And then again from 5 to infinity. Because remember, our boundaries were the negative 4 and the negative 5, not the negative 5 and the 6. Those were our test points. And so there's our solution in interval notation. As a graph on the number line, I basically just need to graph what I have up there and just maybe clean it up a little bit and just shade it in. And so we're not including the endpoints here because we have our inequality symbol does not have the equal to part. It's asking us to find values of x for which this expression is strictly greater than 0. At negative 4 and at negative 5 themselves, that expression is equal to 0. So we want to leave those numbers out themselves, and that's what the parentheses are indicating, both on the graph and in the interval notation.